All right, everybody, we're going to go over 2.7 through 2.10 more derivative rules. And so we're just going to go ahead and fill in each of these derivative rules, remembering from last year what they are. If you want to go ahead and pause the video and take some time to try to fill them in yourself, see what you remember, go ahead and do so, and then we'll go ahead and go over them together. All right, so we're going to go ahead and do each of these. So this first one is our product rule. It can be written in two different ways, but it is the, you can think about the derivative of the first times the second plus the first times the derivative of the second. Or you can actually do the derivative of the second first, so it could be f of x times g prime plus f prime times g. Doesn't really matter which order you do it in because we have addition. We can do it either way. All right, over here is our quotient rule. That's our low d high minus high d low over low low. If you remember it that way, if you don't, then whatever way you have to remember the quotient rule, that's what you want to use. So low d high minus high d low over low low, so low squared. E to the x is our easiest one, just e to the x. Now we're actually going to add one in here. If you have d dx of a to the x, so any base, not just e, but any base, that one is a to the x times the natural log of a. And actually holds true for our e to the x as well, because if I did using this rule, I would have e to the x times ln of e. The ln of e is equal to 1, so then it kind of goes away, just leaves us with the e to the x, right? All right, derivative of natural log would be 1 over x. Sine is cosine, derivative of sine is cosine. It's easy. Derivative of cosine is negative sine. And derivative of tangent is secant squared. And again, as long as you know up to there, you're good. These other three trig ones, if you can remember them, great. If you can't, it's okay as well. So we have cotangent. Cotangent is negative cosecant squared. Secant is secant times tangent. And cosecant is negative cosecant times cotangent. All right, so those are our different derivative rules. So we're going to go ahead and make sure we remember so we can go ahead and use them. All right, so let's go ahead and do problem number 1. So problem number 1 is one of our derivative rules here. So this is actually going to be f prime of 0, and so we need to figure out what f of x is. So this is of the form that if we have the limit, so if I had f prime of a, that we can write as the limit as x goes to a of f of x minus f of a over x minus a. So hopefully we can see that that a is definitely the 0 that we have. So from that limit, we need to go ahead and figure out what f of x is. So if we follow the pattern of the definition of the derivative, hopefully we can see that really our f of x is right there. Because if we think about the 1, that would be 2 to the 0. Therefore, that's our f of a, and this would have been x minus 0. So f of x is 2 to the x. So then if I want to know really what f of 0 is, I need to know, well, first off, what f prime is. And using the derivative definition for an exponential there, that would then be 2 to the x times the natural log of 2. So then if I want to know f prime of 0, then that would be 2 to the 0 times the natural log of 2. Well, 2 to the 0 is 1, so that's just the natural log of 2. So b. All right, how are we doing, guys? Ready to go over them? At least problems 2 through 5. Are we ready for problems 2 through 5? Okay, let's go back to problem number 2. Let's all just check in and make sure we're good. All right, so let's go with Ashley. What would I do for this one? Number 2.
You would do 3 cosine of x plus a e to x.
3 cosine plus what?
Plus a e to x.
Okay. Oh, is it frozen?
Yeah, that was like,
Why is it frozen? Oh, I know why it was frozen. There we go. Okay. All right. And then after that?
plug in 0.
Okay, so 3 cosine times 0 plus 8 e to the 0.
Yeah. And then cosine of 0 is 1.
Okay, so 3 times 1 plus
8 times
8 times 1. Good. So 3 plus 8 is 11. Okay, how did we do on number 2, guys? Did we get 11?
Yep.
All right. Okay, let's go on to problem number 3. Now, I'm pretty sure you all guys got the answer of cosine, right? It is cosine, but we have to do some things before we get there. So there's actually 2 ways you can do this. I assume all of y'all chose to do the product rule, right?
I chose the FRQ and don't simplify rule.
True. Okay, that's a valid point. But what if this was a multiple choice? And the multiple choice was cosine.
Run away from the AP exam.
All right, let's do the product rule. Let's see, Matthew, help me with the product rule. What did you have?
Cosine x times secant squared x plus tangent x times negative sine x.
Plus 10 times what?
Negative sine x.
Negative sine x. Okay. Again, yes, if it was an F or Q and that's what they wanted you to find, can we stop there?
Yes.
For sure. But if this was a multiple choice, they would probably not give that as the answer. So you'd have to know how to simplify this. So this is where we have to know some of our trig identities. So secant, what is secant?
1 over cosine.
Okay, so that's going to be cosine, oh, I forgot an x there, cosine of x times 1 over cosine squared. What is tangent?
Sine over cosine.
Sine over cosine times sine. So what does that simplify to? What happens on the first 2 here?
We get 1 over cosine.
Just 1 over cosine. What do I get on the second one?
Sine.
What's times sine?
Squared x.
Sine squared x. So sine times sine is sine squared over cosine. Do I have the common denominator?
Yeah.
So 1 minus sine squared. What is 1 minus sine squared?
Oh.
Anybody remember?
Cosine 2x. Or like.
Cosine squared times, or sine squared plus cosine squared is equal to 1. So that is cosine squared. Over cosine, so what does that simplify to?
Cosine.
Cosine. Do you want to see an easier way
Yes. Please.
to get to there? Simplify it at the beginning. d dx. What is tangent?
Sine over cosine.
Sine over cosine. So what happens to the cosines?
Oh, there's
What happens to the cosines? So what are we left with? And what's the derivative of sine?
cosine.
Oh, that's. Oh.
Cool thing that they get the same thing though, right?
Wow.
It's just that one's a lot more work. Yeah. You can always see if you can simplify and make the problem a little easier, yeah, for sure. But again, if this was an F or Q, you could stop here. You could have done that and gotten this, or you could have, simplified down to here. But be careful with your mistakes. But if this was a multiple choice, I guarantee that would be your answer, not this. So you have to be careful. Okay. So yes, trig identities do not come up a lot, but they might come up. All right. Problem number 4. Let's see. We'll go with Anthony. Help me with problem number 4. Okay. Plus sine x. Wouldn't that be negative sine x? Okay, times ln of x. So not like the last problem. There's not much we can do to simplify that, right? Only thing I see I could possibly do is write the cosine in the numerator. But that's about it. You don't even really need to do that, right? So good on that one. All right, any questions on number 4? Are we good there? All right, let's look at number 5. Okay, we have h of x. Okay, Kelvin, help me out with this one. What is h prime?
No way. So we did 3. Well, I plugged in 3 first. So we did f of 3 times g prime.
Okay, let me just. Okay, so f of 3 times g prime of 3. Okay.
Plus g prime of g, just g 3.
Okay.
So and then you find the 2 values, f of 3 and g of 3.
Okay.
And then
So let's take a break. What is f of 3?
4.
What was g of 3?
3.
Okay, you also need the derivatives, right? So what is f prime of 3?
2 beta, negative 1.
Okay, what are you looking at to determine that?
The slope of the
Good. And then g prime of 3?
2.
2. Okay, so continue, plug everything in.
And then that's 4 times 2 plus 3 times 1, which is 5.
3 times negative 1. And that gave you 5 because that's 8 minus 3, so 5. Do we agree with 5, guys? All right. Good. All right. Continue. You have problem 6 and problem 7. All right. Just looking at the time, let's go ahead and do these quickly together. All right. So we have h of x is that. So we want to find that. So h prime of x. That's going to be our quotient rule, right? So low, d high. So the top would be 4f prime, right? Minus 4f of x times Low D high and high D low, so that should just be G prime of X. Over G of X plus 1 squared. Does that make sense? Just using our quotient rule. Okay, so if we're wanting to find h prime of 2, then that would be g of 2. What's g of 2?
-3.
So we should have -3 plus 1. And 4 times f prime of 2. What's f prime of 2? So times 1/2. Minus 4 times f of 2. What's f of 2? What's f of 2, guys?
-3.
And then g prime of 2.
2.
All right. G of 2 is -3 plus 1 squared. All right. If this was an F or Q, you could even just leave it there, right? You could also simplify and see what you get. I do want to go quickly over the last one. Is it a quick question, Anthony? And then like G of 2 plus 1. Yeah, I would, if you do not do this step, well, if I'm remembering correctly, some of these problems on the scoring guideline, they do actually want to see that step, so that'd be a good step to see, yeah. So I would write that. Because I think they give, that's one of the points. They say h prime of x, and they give a point for writing out the correct h prime of x. So. All right, on this one, I just want to quickly touch bases. What is our equation, or what do we use to find equations of lines?
Y minus y1 equals m.
Y minus y1 equals.
M times x minus x1.
And then how do we find m?
We solve for the derivative.
So that should be f prime of 2, right? Okay, so just as a reminder with that, we're out of time, but just a reminder that we use that, right? We have to find our derivative, find the slope, plug it in. Now, do you have to use this form? No, if you have another way of doing it, it's fine, but this is a form that you will want to be familiar with, because we're going to be using it more when we get into further stuff down the road.